Hello, 5th grade. This is Chapter 8, Lesson 5, page 577. Least common multiple. A multiple of a number is the product of the number and any other whole number, like 0, 1, 2, 3, 4, etc. Multiples that are shared by two or more numbers are called common multiples. The least common multiple, LCM, is the least multiple other than 0, common to sets of multiples. So what does all that mean? We will find out. So I think of multiples as being like the answer to multiplication problems. So like I know that 2 times 6 makes 12. So 12 is one of the multiples of 2 and 6. They both go into that. But 3 times 4 makes 12. So 12 is a multiple or an answer that 3 and 4 also go into. So that's how I think about it. And we're trying to find the smallest multiple that that two numbers will go into. So the least common, the smallest. Here we go. Example 1. Tom hits golf balls at the driving range every 3 days. Practices putting every 4 days and goes golfing every 6 days. If he did all 3 activities today, in how many days will he do all 3 again? So, Tom likes to golf, so he hits golf balls at a driving range at a place where you just go hit golf balls every 3 days. He goes to the driving range. That's where you stand at the end of a line and everyone hits forward and you try not to, get in the way of anyone else's ball, and you probably won't if you stay in a straight line. He practices putting every 4 days. Side note, putting, trying to get it into the hole directly from close range usually. And goes golfing every 6 days, the actual game every 6 days. If he does all 3 activities today, like on one day, how many days will it be until he can do all 3 activities again, like that he's done all 3? When will that happen again? In how many days will he do all 3 activities again, like on the same day? Because he's got a rotating schedule. To figure that out, you want to find and circle the least common multiple of 3, 4, and 6, the numbers we are working on. What is the smallest thing that they all go into? And we're going to do that by listing non-zero multiples of each number. So when you're memorizing your facts for multiplication, you'd say like 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. I'm going to say this number first. 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, 3 times 8 is 24, 3 times 9 is 27, and then I usually like to end on 3 times 10 is 30. Hopefully we won't have to go farther than that. For the 4s, I can do these a little faster. 4 times 1 is 4, 4 times 2 is 8, and I'm just going to keep listing them. 12, 16, 20, 24, 28, 32, 36, I almost made a 2, and then 40. That's the multiples up to 4 times 10. Let's list the 6s. 6 times 1 is 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Okay, I listed all the multiples. I probably wouldn't even have to go quite that far but we've got them all listed up to the 10 times that number. And we're going to see what's the smallest one that they all have in common, the least common multiple. Let's see, I've got 3, nope. Is there 4? Nope. 6, almost. 9, nope. 12, hey, they all have 12. 12 is the number that they all have in common. So I'm going to circle that with a marker just so we can find it. That's the first number and the least common multiple, the smallest and least common of all the multiples that they go into. So Tom will complete all 3 activities again in 12 days. That's not quite 2 weeks. So in 12 days, he will have another day where he does all 3 activities in one day. That's interesting. Check. The number line shows on which days all 3 activities will be completed. So this is another way of looking at it. He starts on, day 0 today, doing golf, putting, and the driving range, all on day 0. And then they laid it out. The driving range was every 3 days. The putting was every, let's see what that is, 4 days. And playing the actual game of golf was every 6 days. And they laid that out. And so visually, you can see the next time that all 3 of those activities will happen on the same day is on day 12. So that's a nice way to see that also. It proves that least common multiple works. Okay, turning the page. Here we go. Trying to figure out how to line this up, sorry. Okay, here's another way. Find the LCM of 15 and 40. Write the prime factorization of each number. So we've done this before. 15 is equal to 3 times 5. And it's already prime because 3 and 5 are prime. 40 can be made by multiplying 4 times 10. 4 is broken down into 2 times 2. And 10 is created with 2 times 5. So these are all prime now, 2, 2, 2, and 5. Find the common prime factors. What do they have in common? For 15, they have 3 and 5. We're just sort of rewriting them. For 40, we had 2, 2, 2, and 5. The only common prime factor is, the only thing in common is 5. Find the product of the prime factors using each common prime factor only once and any remaining factors. So this is the one they have in common, and they only want us to multiply it one time into this group and find the product of the prime factors. So we're going to list all of them using each common factor, prime factor, only once. So these can only be used once, the 5, and any remaining factors. So we can list the 5 because that was the one that was repeated, just for the fun of it. Or we could have put it at the end, it doesn't matter. And then I'm going to do 2, 2, 2, and 3. Now, I put 5 first, but technically I think if I had to multiply this, I'd prefer to start with the little ones. So I think I'm going to do that right now. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40, which is a nice even number. And then 40, which all of these make, is 40, times the 3 that was left. I know 3 times 4 is 12 with a 0. Add the 0 on. So their lowest common multiple that that 40 and 15 would go into is 120. That's a big number. But that's the smallest thing that they would both have in common as something that they would multiply out to be. Something times 15 makes 120, and something times 40 makes 120, and that's the first time that they would have a multiple in common, an answer in common. Okay, let's continue. Sorry, the table's shaking. Find the lowest common multiple for each set of numbers by first listing non-zero multiples of each number. So this, we're not doing the prime factor thing, we're doing the listing. Okay, I'll do one of these and then move on to the other page. Or will I? Let's move on to the other page. Well, no. Okay, I'll do this one. It should be quick. Okay, I'm going to list these. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. I'm going to go a little further. 24. My brain is kind of freezing. 30, 36, 42, 48, 54, and 60. Going off track a little bit. For the tens, we've got 10, 20, this is easy, 30, 40, 50, 60. Do we have one in common yet? Because I would like to quit. Let's see, is there anything in common yet? Do they match up yet? Ooh, they do. We've got 30 and 30. 30 is the lowest common multiple, the lowest thing that they both go into. So 30 and 30. So the LCM, the lowest common multiple of 6 and 10 is 30. I could have kept listing them, but I'm looking for the smallest one anyway, so that worked. Let's go over to this page and we will try on the next one, we'll try using that prime factorization method. The thing with that is you need to remember that you can only write the one that they both have one time into the grouping. So that takes a little memorization. Here we go. I'll do number 6, 12 and 15. I'll do this with listing, and then when we get to multiple ones, this one I think I will use prime factorization. So let's try number 6. We have 12 and 15. Moving my book. $12 and $15. Okay, let's see how this goes. So for number 6, we have 12 and we have 15. And for these, because they're small, I'm going to list their multiples and see what the first one is that they both have in common. Wow, this could prove to be tricky because my 12s don't come out that fast, or my 15s. Let's see. See how many I can list. This would actually be something I might actually want to do prime factorization on. But, oh well, here we go. For the 12, so I'm going to pull up a calculator just because I want to make a point. In case I need it, I'll have a calculator. Okay, so we've got 12. I should know these, but I never worked on them that hard in life. 24, 36, 48, sorry, 60 would be next. 72. Let's do some 15s and see if we find one yet. 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. Yay! I see one right away. So I'm going to stop listing there. The least common multiple that 15 and 12 have is 60. That's the smallest thing they both go into. So the LCM for those two numbers is 60. The lowest common multiple of 12 and 15 is 60. All right, you'll be using these for other operations in the future. So let's go on. How about number 11? Number 11 is 15 again, 25, and 75. We're going to list out the prime factorization for this, like prime factor tree. Here we go. For 15 we have 3 times 5 makes 15, and they're both prime, so we're done. Wow, for 25 this could be easy too. We've got 5 times 5 makes 25, and they're both prime also. 75 takes a little more work. I know 3 times 25 is 75 because like 3/4, like the quarters you carry in your pocket, makes 75 cents. So I know that one. 3 comes down, we reuse it. We're just relisting it. Now we break up the 25 into 5 times 5. And that's equal to 25. So we're done. They're all prime. What we have to do is list. Well, we can list them. Probably don't have to relist them if you could see it, but we're new to this, so we'll write them out. For 15, the prime factors were 3 times 5. I'm thinking about whether we put commas or what between them. Nope, little times signs, okay. For 25, we had 5 times 5. For 75, we have 3 times 5 times 5. When you choose to make your lowest common multiple, they said if it repeats, you can only use it once. I see 3. I see 3 there. 2. I can only use one of them, so I will write down 3. I see 5. I see 5. I see 5. I see a lot of 5s, but they all have it. I can only use one of them. I'm up to 15, but I need to keep on trucking here. Find the product of all the prime factors that they have in common, using them only once. And any remaining factors. Okay. I'm looking. So lowest common multiple. This is coming out funny for me. Once again, I've got my prime numbers. The only common prime, let's see what prime factors they have in common. 5 is in common for all of them, and 3 is not in common for all of them. The 5 is listed for all of them. I can only use it once, but the 3 is not common to 25, so I can list all the 3s. 1 3, 2 3s, and 5 is repeated on all of them. Let's see what 3 times 3 times 5 is. 3 times 3 is 9. 9 times 5 equals 45. I think we need to keep on plugging along. Let me double check this. Maybe we need one more 5. There's a 5 here. Okay. So the ones that are in common, you can only use one time. But the extra can be written into the equation still, written into our final answer. They did not all have a 3, so I listed both 3s, and I have 2 extra 5s left over. So far, I have done 3 times 3 is 9, times the 5 is 45, and I added an extra 5 on there. Wow. What's 45 times 5? We'd have to work that out. And I could use a calculator, or I could just do the work. I'll do 45 times 5 here. 25, 20 plus 2 is 22. 225 is the least common multiple based on our prime factorization. Wow. And I guess that makes sense because we've got 75, 25, and 15, and the first thing that they all go into is 225. Let's continue. Let's try some more, because this is where the problem lies. Is you can see I'm hesitating. It's been a while since I did this. We need to remember how to use those prime factors to find the lowest common multiple, and that's where it gets tricky. Listing them out is actually simpler, but when you get into these large numbers, trying to list all the multiples of 75 gets really big, and you really would need to use your calculator over and over to continue listing them all. So let's do another one. Working my way over there. How about number 12? Number 12 is 9, 12, and 15. You can list them, or you could do the prime factoring. Let's try the prime factoring again, because that is more detailed. So I'll start with 9. 9 is made with 3 times 3. It's the product of 3 times 3. We're done. That's prime. Those are both prime. 12 is the product of 3 times 4. That's prime. I'll bring it straight down, and I need to break 4 down into 2 times 2. Okay, those are all prime. We are done. And then we have 15. 15 is the product of 3 times 5, and those are both prime. Then we list them all, which needs to be done, or you could just leave it. Just trying to think of how it's maybe easier to see if they're all sideways, but you could go through here. What we're trying to do is any number that repeats among all of them only gets used once. So I'm going to circle this 3 and this 3 and this 3. Those are the 3s that they all have. They all have at least one 3 in their prime factorization. So when we figure out our LCM of these 3 numbers, we're going to write 3 as the first thing we're going to multiply, the first factor. Is there anything else they all have in common? We've got another 3, but this one doesn't. We have another 3, but this one doesn't. So we get to use this 3 because it's all by itself. And then we have 2 2s that are represented here by the 12. And then we have a 5. We have to use all of those, but when they're in common, we're only allowed to use it once. So that's why that was listed one other time. So here we go. 3 times 3 is 9. 9 times 2 equals 18. So I did that. And then I have 18 times 2. That's trickier. 36. And then I finally have to do times 5. 36 times 5. Oh boy. I have to do the long multiplication. That would be 30, 15, 60, 18, 180 is what that equals. So the lowest common multiple of 9, 12, and 15 is 180. Wow, that's big. But that's the smallest thing that they all go into in common. It's the first thing that they all have in common that they go into. Hard to believe, but 15 is an odd number, and it's rather large and amazing. Okay. Let's try one more. Or not. Let's see. I think I'll just do one more thing. I want to see these listed just to verify and show to you that this prime factorization works. So let's try this. I've got the calculator. I'm going to clear it from the last one, and let's list some multiples of 9. We think it's 180 right now, so I'm going to move this down. Let's list them all. Here we go. Well, 9s are kind of easy. 9 times 1 is 9. Then we have 18. Listing all the 9s. I'm going to end up smearing my hand across here. 9 times 3 is 27. I got to get my brain going. 36. And let's see, where are we at? I just got distracted. 40. I don't even know. Where am I? 9 times 1, 2, 3, 4, 5. Oh, easy. 9 times 6 is 54. 63. Oh boy. Look how long it'll take me to get to 180. I think it'll take forever. I don't even want to continue. Oh my. Let's list some of the 12s. 12, 24, 36. 12 times 4 is 48. 60, 72. Where am I? 84, 96, 108. That's as far as I can fit right now. 15. Well, we've got 15 times 1 is 15, 30, 45, 60, 75. Do we have anything in common yet? No. And once again, I don't think I want to keep going up to 180, so this just proves why using the prime factorization is way simpler once you get the method of writing them out memorized. And remembering that you can only use the prime factor that repeats itself on all of them one time. And the rest of them can be written one time just to make sure they're all represented. Oh, I'm sorry, I'm pointing up here, but these are the prime factors. So, hope that helps you, and we'll see you in the next lesson.